Good morning from TechCentral and welcome to our Living on the Edge webinar brought to you by SUSE. Thanks all for joining us today as we find out if edge computing is all hype or the key to a high-speed future.
Good morning, Carrie, and to all of our attendees. Thanks for joining us today. As we've established, we're scattered around the globe. It's probably not as good as the coffee in the Saxon or a face-to-face with all of you, but thank you for joining us. And I'm so glad we are joined by Matthew and Christoph. Matthew is going to look after everything business orientated in today's discussion, and Christoph is going to dive into any of the technical questions that we have. But before we dive in, I wanted to take a step back and how we got onto this topic. If you're not living on the edge, you're taking up too much space, said Matthew Whitaker, who's a US climber. And in preparation for today, I was looking for SUSE's predictions for the edge and where it's going. And a year ago, there was an article posted by SUSE that's saying on average 2,617 times a day, we swipe, click, or tap our mobile phones around the world. The prediction is that we are going to be creating 930 exabytes of data by 2022. And that's about 20% of all the IP traffic in the year. But the stat that stood out for me is that IoT, so Internet of Things spending, will reach about 745 billion in 2019. Now, I don't know if that number was hit, but the prediction for 2022, which is only next year, is that we are going to have 31 billion endpoints of data creation that we're going into. So what that speaks to me of is an explosion of data points, data collection points, data origins, and areas where data is going to come in to be consumed by the business. This leads to muddied water for me. And when we were in preparation, Matthew, Christoph, and myself had some differing points on what edge computing is. So I'm going to start with you, Matthew. What is edge computing to you as a business leader?
I reckon you can wrap up edge into sort of two areas. I think speed is one and insight is the other. So edge kind of brings those applications closer to the data, which is kind of a new frontier where distributed IT infrastructure can be deployed much closer to the action, so to say. This obviously enables faster insight, response times with less bandwidth instead of sending that sort of data to the data centers. Edge computing obviously decentralizes this processing power to ensure real-time processing without that latency that you would typically get over a LAN in terms of sending the data. Edge is obviously also important because it creates that sort of new, improved way for enterprises to maximize their operational efficiency, improve their performance, and even automate some of those processes that might have been a very manual process in the past. And at the same time, you need to kind of provide that always-on availability. But I want to make one thing clear here. You're not replacing your cloud strategy, but you're rather augmenting it. Our example as a company of the acquisition of Rancher, some of these containerized applications will be designed for distributed computing at edge locations. So being able to have one standard, secure, policy-based platform running anywhere is a huge benefit for any enterprises embarking on that digital transformation journey. So don't make the same mistakes of the past and try and merely change the destination of your compute core, but rather look to bring all those aspects of your infrastructure into one platform, from the edge to the core to the cloud and beyond.
Okay. So Christoph, as a technical bias, where does that sit in your world? Where does edge kind of become mainstream for you?
I kind of agree with Matthew. Since the application of Internet of Things devices, like you said, and services and application in complex scenarios such as smart cities, smart energy, smart farming, or Industry 4.0, also like healthcare or transportation, has generated new challenges for solutions based on cloud computing, basically. So before the emergence of edge computing paradigm, cloud computing as a centralized structure where computing and storage were only deployed in a centralized and distributed server on the remote cloud. But cloud computing presents some drawback when dealing with IoT application, actually, as they usually require reduced latency and response in real time. So the edge computing paradigm emerged as a solution to this problem, being presented as a set of technologies that help to optimize computing and storage process prior to send them in the cloud, basically. So this is basically achieved by preprocessing data collected by device prior to be sent into the cloud. And the edge fits in everything that it's not cloud.
Okay, so I cry through a medical drama at least twice a week, which we watch as a family. And all the doctors are walking around with their iPads when they are doing their diagnoses. Now, I haven't been to a hospital, touch wood, in a while. Are you saying that the technology is there to make the hospital totally digital? We are taking time to update our processes to get there, or are hospitals now enabled for it and they just need to roll it out in order to take this digital transformation? It's no longer the cloud journey or the digital revolution. It's just operations as today. How close are we to getting it as normal run-of-the-mill business engaging with edge computing, Matthew?
I think everybody's on a journey. And I think if I use an example, another example, actually allow me to use it. It's a major transport company in South Africa. They've put sensors on all of the movable devices. And I mean devices, I'm even talking cars and cranes and conveyor belts, etc. They've actually put sensors on all of these devices. So if a shipment comes in of aided something, let's just use coal, for example. If shipment comes in from coal, it comes in on a train from Ermelo, Witbank area, ships down on a train, gets loaded off onto a conveyor belt. That conveyor belt has all sensors on so that it can monitor the bearings of the sensors, wear and tear. It pushes the coal over the edge. It drops onto an automated truck. That truck obviously has sensors on the tires, sensors on the rims, sensors actually to monitor tire thickness, so that if that truck doesn't park directly underneath where that coal lands, for argument's sake, and lands a little bit more to the left, back left, that back left tire is going to sort of be replaced. So it's all about preventative maintenance in this example. You know, this is an insight that you get. So to my point earlier on about this is exactly the kind of insights that people can now start taking and saying, we just need to replace one tire. So when we send our truck in, the whole truck's not gone for the whole day. It's just a matter of getting one person to replace one tire. One bearing's gone over here, or whatever the example that could be. But that's exactly it. It's the power of the insights that provides to you and that gives you as an organization, which obviously can lower the cost of running your business.
So that predictive maintenance and that preventative maintenance in real world operations, we're seeing that today. And you know what was going through my head there when you're talking around the tire? At 1,200,000 Rand a tire or 100,000 euros a tire, that's a big impact it can have on your cash flow. It can have on where you're spending your money and where your materials are or your operational equipment. I really like that. Are managers keeping up with the deluge of information that's coming in? Have we given our management teams sufficient insight into how to change the way they react to these sensors and these alerts that they're getting, or are we lagging as humans?
I think the preparation is happening, and I see it in more and more conversations I'm having with clients. They definitely, and absolutely, I think managers are preparing for it if they aren't already prepared for it. What I've just given you is a company-wide experience, but if you actually look at a home experience that we're intricately involved in day to day, look at the new cars that are coming out. They're giving you tire data sensor just as a very rudimentary example. So these things are coming. When it becomes very user accepted, it becomes more business accepted. And I think that's exactly the same case that will happen in this. So yes, I think the managers are getting the right insights. There are more and more applications out there that are providing and giving these kind of graphical interface and data insights for these people. So yes, I do believe that people are there. And if they aren't,
awesome.
They're going to be there very soon and should be.
That's awesome. Christoph, with all of these changes that are coming and the new sensors that are being deployed and operationalized, the data that's coming back, has our development cycle changed in the past couple of years? And are we embracing new methodologies to enable edge as part of the development cycle?
Yes, good one. So could our customer be a new player in this market and be cloud native and edge compliant by design? I mean, scalability and latency aware. or an existing one that has to deal with legacy technology. In any case, what we observe is the project methodology is still leveraging the trend of the last year, driven by the time to release from waterfall to agile, basically.
Okay, so we're seeing more and more agile coming out, but there's still a space for the waterfall to go. Are you seeing it, Matthew, in a South African context? Are we taking more agile as a matter of course, or are people just using a blend, a mash?
Yeah, well, at this moment, it's definitely a blend and a mash, as you say.
Okay.
Yeah, definitely. I think the agile approach is certainly there, but one thing we cannot forget is the people factor in this whole process. You know, there are tools out there that will provide you your agile development framework, but you certainly can't forget the people approach to that as well. So, yeah.
Okay, cool. So as it becomes more mainstream that we're just accepting that we're developing these things, we are just building it into the process and just carrying on with it, maybe getting a little bit faster because we're using agile, but it's no longer this holy grail of a select team of covert agents that's rolling out edge technologies. We're expecting it to be rolled out. I like that. Now we can release early, we can release often, we can make the mistakes, we can get it back. How are we ensuring that we're getting quality code out there whilst trying to embrace edge technology?
So as the first independent open source software company, we bring enterprise lifecycle and quality insurance on top of open source project. So we also enrich our deliverables by adding quality and security certification. I mean, compliancy in regards of government standards and these kind of things. Life cycle, long-term life cycle, many years, 10, 15 could be discussed. Then how our customers are going to leverage this and success with. So this is going to be driven by the criticality of the workload that the device is carrying. And our engineering and professional services would help them achieve their objective. Could be commercial on the shelf or tailor-made Linux. It makes sense.
So, yes. Definitely. I don't know if you want to add anything to that, Matthew, or can I summarize what I heard from Christophe? So what you're saying is that the fact that we can release quickly because of containerization, reusability, all of these enhancements doesn't take away from the fact that our management needs to be in place to ensure that we're testing correctly. Whilst we've got all the tools and all the enablement, we still need the people to be doing their jobs, and that hasn't changed.
Yes, exactly. Yeah, you need to still operate, and you will have some predictability of maintenance with the MLOps. You will take benefits from this, but in terms of quality, and when I hear about quality, I'm thinking about highly critical workloads like car driving peoples and stuff. Here, you are obliged to prove the quality in terms of ISO, in terms of compliancy with the Department of Defense, American, for example, could be for many different kind of usage. We have to comply with standards. That's the first step of quality of code. What we deliver to the customer is high quality enterprise grade code. Then what they do is either we help them achieving this with a co-engineering or professional services, or they do it on their own. They can be sure that they start with high quality code, basically common code based on all their applications that they can do.
Excellent. I've got a question from Hemu, which he's saying, in which industries is there a higher take-up and processing of edge computing and IoT? I'd like, Matthew, you to answer it from your SADC side, and then Christophe, if you could answer it from a Europe side, because I think the markets are pretty different and there may be differences.
Definitely in SADC, we see more manufacturing. We see a lot in retail. And I would also add into that banking, financial services. Those are typically the three biggest areas because they have the most to lose if they don't make this journey change.
So where in financial services, Matthew? Sorry, financial services is quite big.
Yeah. So if you look at, as an example, mobility
okay.
in a banking environment. I mean, retail environment could be, the financial could be also taken into that sort of financial aspect of retail.
Awesome. Christophe, in Europe?
Yeah, that's Matthew answer is interesting. In Europe, what I see, it's more ground transportation. From every kind of ground transportation, could be train, cars. till even aerospace. Yeah. This is the main one currently, but it doesn't mean that we are not focusing on healthcare and Industrial 4.0, smart city and smart energy also. But yeah, big focus on the car manufacturer.
What is Industry 4.0 for you, Christophe? You just threw that out there. I'd just like to understand it.
That's for me, that's the software-defined industry somehow, that the common pieces of technologies that will be found in different verticals that industrial brings. It could be the transportation, healthcare, all of this, all that belongs to the industry.
So when we get to a smart municipality type of idea in South Africa, we have municipalities that look after suburbs or sections of the city and are managed from energy, refuse, water, that sort of stuff. We're talking around those verticals that are enabled for end-to-end IoT.
Yeah.
So without a shadow of a doubt.
Is it? Yeah. And do you think, Matthew, getting on to smart cities, do you think we are seeing any take-up of any municipalities that you've seen? Do you think that South African cities are ready for this on a mega scale, or are we still points of excellence within there?
Yeah, difficult question, because it obviously alludes to some of the challenges that we have in our municipalities. But I think any clever municipality would certainly start looking at this, especially around waterworks. I mean, knowing where things are broken, knowing where there's leakage, knowing where there's quality issues, all of those kind of aspects are key to delivering an effective service to a citizen. In terms of the smarter cities, yes, absolutely. I think that's a quick start. If we look at, I think it was City of Cape Town would lead that in terms of the journey that they've had around linking emergency medical services to the fire aspect, to the traffic, to be able to get that all together was a hell of a good project that was delivered. And I think that's a leading example of what can happen.
Yeah.
But it shouldn't start there, actually. And it shouldn't be limited to that only. I mean, just Joburg Water or your local water provider can make the difference as a pocket of excellence with inside of that already. You don't need to boil the whole ocean. You need to, as it's a journey, you have to start somewhere.
If there are any salespeople on the call today and you've had a look at News 24, maybe water in Cape Town needs a call. People have been advised not to drink the water because of the funny smells and the taste. So maybe we need to get a couple of sensors out there. We've just had in the chat, what is the definition of smart city from an IoT perspective? Christophe, I'm going to let you take that from a tech perspective, and then Matthew from a business perspective.
So smart city, smart comes first for intelligence. And when we say intelligent, we mean like gathering data at first. It's gathering lots of data. At first, it was university campus that was smart, and all the locks for every door, the badge you're going to use for food, and the track on you on the campus, and everything was basically easy to collect because you own the campus and there is a kernel, an Ethernet ring with a high bandwidth and low latency around the whole campus. So as long as you can have high bandwidth and low latency in your town or something, you can transport data coming from every kind of sensors. Could be camera, could be like, I was in a town in Thailand where everything is basically digitalized. From the bus you take to you use your mobile for everything, for paying for everything simply.
Wow.
And even unlocking your door. The house you rent, you can unlock the door just with your mobile. So smart city, yes, it's everything is interconnected. But for this, you need at first a high bandwidth and low latency interconnection between all of this stuff. Yeah.
So this debate that I've been ignoring on the 5G rollout becomes critical if we want to get smart city and get edge enabled. We need bandwidth and we need low latency to make it operational. And then we can go mad with it. I mean, the use cases are endless.
So Christophe has quite correctly touched on some of the foundational stuff that's important. But I think if we look at the question, what's the sort of the definition of a smart city? It's really utilizing the functionality that a city should have in its information technology, right? And it's really there to improve that operational efficiency and provide better quality of service to the citizens. So I think that really, if we look at what a smart city actually does and is and should be, it is exactly that. It's about using the information that it has to be able to share with the public that it services and provide that better quality of governance and service to the citizen for their better welfare. I think that's a great question of what a smart city should be.
I really like the vision that Christoph has painted for it, which is smart everything, but I like that definition, because the next question I had was this innovation cycle. We all want to jump on the bandwagon. We've all got ideas. We've all got irritations that are out there. Are we not tempted to get careless and just release anything and put sensors on everything? And is there not a deluge of useless data gathering going on, Matthew?
So, I mean, if we look at some of the mistakes, the common mistakes that people would do in terms of taking an edge strategy into their business, I mean, the one mistake is absolutely to do too much at the edge. You know, you've got to keep it small, cheap, and easy to replicate. Companies that are too much processing on edge sort of devices soon find that latency and speed issues that they were looking to solve with this edge computing strategy actually come back in a new form, and actually in most cases sometimes even make things worse. And that goes to what Mo was saying earlier on about these 90,000 devices on an oil rig. Absolutely, 20% of that data is seen. You know, while I don't discount that an oil rig does need as many devices for safety, for health, and obviously production purposes, it's critically important to know that, you know, you can't just, like I said in my opening statement, you're not replacing a cloud strategy. You're just augmenting it and choosing the right and choosing the right functionality for that edge. It's there to augment your environment. It's not there to replace. And don't from the core and throw it all to the edge, because then you're just making things worse in another form.
We're shifting the problem, making it from, instead of the back office problem, now someone in the front office. Matthew, you said the cloud strategy, you've said it a couple of times, the digital transformation. Haven't we moved past that? Are we not into it's the strategy, it's our transformation plan, it's our business plan? Or are we honestly still looking at a cloud strategy and then an IoT strategy and an edge strategy?
Yeah, I think you absolutely are. You're needing to have all of those, and your enterprise architecture needs to bring them together. You know, there are definitely going to be three pockets of strategies within inside organizations, as you've mentioned. The cloud, the edge, and IoT can kind of be together. But, you know, then you bring in the other aspect of what that does provide for you, and that brings that AI, ML side of things, which we haven't really touched on, but there's also an aspect that does need to be brought into the fore as well. You know, are those organizations utilizing that and automating any of those processes that they've normally had in a manual manner?
Yeah. Well, that brings me on to Rilani Mnisi's question, which was, what are the cyber threats that are faced with edge computing? Because if we're starting to get into this where we're going on the cutting edge, so on the AI side and on the automation and robots and that, are we not opening ourselves to a plethora of attacks?
I would think so, but again, security needs to be a major part of that as well. And I mean, as a second mistake that people are doing is they're neglecting that security at the edge. You know, typically it becomes an afterthought, you know, and they're not managing that. Those consequences actually get worse by neglecting.
So, Christoph, when we are deploying IoT as a solution, are you seeing your customers putting security at the forefront of this, or is it, as Matthew says, quite often an afterthought? And what are some of the new threats that we're facing from edge computing?
The more you interact with humans, the more you have to prove to authorities how secure and safe your systems are. And both aspects are different. Security, it's about protecting the data, when safety, it's about protecting the lives. So to answer the question, there is an interesting example. Tesla a few months ago who voluntarily recalled more than 130,000 of cars due to safety issue. I can't imagine how much that cost. And considering that it was due to lack of test, basically they have a 8 gigabyte EMC and they have to recall 30% of all their car to change memory cards in it. I'm sure that now they have implemented a special memory test, you know. Security, safety, it's true, we are talking about cyber security. And when we talk about security and safety, we talk about isolation. And I can agree that it's true until now, until I mean, it's a pity if you don't think about security when you are designing the things. If you think this afterward, you will have constraint, and especially in edge due to hardware things. For example, in car and planes, you need to prove that you have hardware isolation of your workload so that you can prove the determinism of things, so that you can say real-time stuff, basically. You can predict what's going to happen, and there is no latency in your thread, there is no latency in your process. So at the end, you can predict what's going to happen, and you need to predict what's going to happen if you're carrying lives, basically.
We had a comment from Terry White, which is saying the edge grows your organization's cyber attack surface exponentially. So security is probably the primary concern of implementing edge. So it's more of a comment. And I tend to agree with you, Terry. I think that any team that's taking on edge in any way that doesn't have a security bias to it is naive to the fact that they're going to be opening the network at every area. So thanks for that comment, Terry. Hemu has asked another question, which is way out of my pay grade. I think it's going to be Christoph. What are your thoughts on quantum computing and how it plays out with regards to mobile devices and deployment of containers on?
Quantum computing and container, I think we need a couple of years to put them in the same sentence. So far, it's more weighted in the cryptographic area, what we can do in terms of key exchange. There is solution, but again, I don't want to dive into the science fiction part of this with key exchanging from satellite and then measure the derivation of clock in a quantic way. So I don't see an application like quickly on the edge side, but for every cryptographic stack where you need HSM and this kind of hardware security module and stuff, yeah, it's potentially we're going to see quantum computing coming in the upcoming years. Yeah.
Christoph, that's an excellent answer. I think the temptation is that we go too far and we forget about the incremental improvements we can make. And there's going to be a small area where quantum is going to be played out. And it's probably in a couple of universities and one or two amazing forward-thinking, grasping organizations. But in today's world and what we're talking about, there are real benefits that can be given right now. I saw Matthew's Garmin watch just now. I think we take it for granted how much data we are collecting in our personal lives. And, you know, if Strava gets my run this afternoon a little bit wrong, that's okay. But if the IoT device, which is a pacemaker for a friend of mine, is not giving the right information, that can have a serious consequence on this man's life. So the testing that you're talking about and getting the basics right, Christoph, I think is pretty fundamental. It is fundamental. That being said, I wanted to see if Matthew would jump on and say that we are now just strategizing for IT for the future, but you're still breaking them into cloud, into IoT, into other areas. What impact is SaaS and the SaaS options having on edge innovation?
I will consider SaaS like in terms of software as a service that could rely on public or private cloud. So SaaS offer a great backend for every offboard edge architecture. So I will put offboard in front of onboard. Imagine a car, imagine a boat, imagine everything. You have onboarding stuff where you're going to compute things locally, and then you're going to offload the things to an offboard architecture. In healthcare, for example, if you take the example of an RMI system, you enter in, they do the magnetic imaging, and they won't compute this before they computed it locally on the machine. Now we think about offboarding and offloading the chunk of picture and computing them outside of the RMI. Why? Simply because if you change a little piece of an healthcare material, you need to recertify the whole stack. So if we externalize such pieces, we can update this and have a different life cycle here. So the SaaS, when I hear SaaS, I think about how can this bring computability and storage into an offboard architecture. So it helps here, depend how you consume this. You can consume this like I put all of my chunk of picture or sound or whatever, and then the modelization behind the computer, we're going to compute, make a model, predictability, all of this. And then there is the approach like REST API. Basically, we have an API opened and we just send stuff like small sensors, like this kind of small sensor. They will send data like MQTT data, different kind of things. So SaaS, it's always interesting, especially when we compute data locally before sending them to the cloud. Yeah, it can't be decorrelated from SaaS architecture. Yeah.
That's awesome. It's probably not the forum to discuss it, but the commercial risks of rolling out IoT in a SaaS environment with the commercial models where we have pay by use or pay per gigabyte or pay per something without a tap turning on and off can also be quite scary for CIOs. And I think maybe we should delve into that at some stage on how we manage that risk. I don't think it's today's discussion, though. Christoph, would you say, bearing in mind unlocking SaaS, using it effectively, having these devices, getting the architecture out there, getting the processes reimagined, organizations are now ready for mainstream large-scale AI deployments?
I would say when we talk about AI, again, it's artificial intelligence. It's not a smart something. It's about gathering data. So the journey starts with how do you gather, clean your data, store your data, how you can make a model out of your data. If your data dictionary or if whatever in your data set has any biases or anything, at the end, your machine learning model would work, basically, because the algorithm would work, will make it work and run, deployable, everything, but it's going to be wrong. So everything comes with your data. And we can help you, gather. You have this AWS Greengrass story where they put FreeRTOS on the microcontroller. They gather all the data. Then we transport the data at SUSE. We're going to be the piece of infrastructure hosting, I don't know, Confluent Kafka, could be also Redis or whatever. We make the data transportation. And until the data lake, basically, we will compute the data locally. We'll start to anonymize some of them and then check for biases and stuff like that. But then we're going to infer stuff on top of this data. We're going to consume this data into some neural network model existing and then give us the algorithm out of this. So all the company caring about their data are enabled to go on the AI side, I think.
Matthew?
There was a very interesting report that came out a little while ago, but it said around about 3/4 of companies, let's call it 75% or so, they all viewed AI as critically important, but actually only like 1/3 of them were ready to basically address that requirement. But automation was what came out key. A lot of these companies believe that automation will definitely have a major impact on the jobs over the next couple of years. But I think what's important to know as well is that AI is actually not a solution in itself. You can't just switch on AI and kind of get it to work. Using AI gets businesses involved in actually cleaning up that data and then creating those algorithms that will actually make those business processes better for the organization.
The hardest thing for me is for people to admit that their data is actually not as amazing as they think it is. We had a session a couple of weeks ago and we were saying, when do you see that you're going to have a tough project? And when you walk in the door and people don't acknowledge the problem that they have with their data, and our data is fine. If anyone's data is fine, then they've probably got an app like Terry's saying, which is clean their data. But I think that data is the root. It's the building block. That was my next question, which you've just stolen. What do we need to check before deploying AI? Matthew, have you seen any big mistakes in our region with regards to deploying solutions with IoT and AI as the end vision, as the end enablers that we want to get to?
I think lack of a good architectural approach and old-fashioned pragmatism, big problems. We see a lot of delayed projects exactly for the basis that we've just spoken about. The data sort of hasn't been ready and people have not been ready. So while the goal and the idea is to reach a certain utopia, it's definitely not as easy as people believe it to be. And that's why you have to get the experts involved. Get a good company that can walk that journey with you. Get a good company that can actually help you and challenge you and be ready for that challenge. Be ready to be humbled. That's the main important thing as well. Be humbled because you're getting these people in to provide a service to you. Listen to what those answers are.
Yeah, it's like going to the doctor, being diagnosed, and then ignoring them. Not that, Christoph, you would do that, because the French are much more sensible. Have you seen any big mistakes with companies deploying an edge solution?
So I will not comment on the dataset quality, but yeah, I will focus also on the architecture, which for me, there is a huge amount of infrastructure and tooling that an AI developer or edge developer needs to deal with. It's very rich and complex environment and development stack. So since all of these technology are cloud native and rely heavily on container and container orchestration, the common mistake is the non-evolutivity of the platform. The AI developers who are not aware, if they are not aware of the standard in cloud native infrastructure, then upgrade and update will be heavily compromised. Simply because there is a lot of libraries, there is a lot of Python configuration, Python's module, and container version. If you do it in your garage and on your laptop, it's going to work on day one. But then if you have to update anything or change some pieces for security reason or scalability reason, it's going to break. That's why we have an initiative at SUSE and Rancher. It's called the project K3 AI. And it's all-in-one piece of technology where we have a bundle of all of this: TensorFlow, Jupyter, K3S, and the operating system. You have everything in one distribution. It's called K3 AI. Give it a try, and that enables every developers to go fast on the developing for a model and the predictability model. Yeah.
So, Christoph, if you had to plot away an enablement way for a developer who's maybe in the audience today, who wants to become one of these new cloud native ready developers, where would you start your learning from a perspective of getting up to speed? Is there a course, or is it all self-study and find out for yourself? Or I know that you've got a very in-depth library and a university at SUSE, but how would you start? What are the building blocks to enable someone to get it right?
I would advise to give a look on Udemy and Coursera, basically. There is a multiple course around TensorFlow and Kubeflow, all the inference piece of technologies that will help you build your model. At first, it's going to be have an understanding of which kind of AI do you want to do. Computer vision, sounds, healthcare data, depending of what you're going to do. You're not going to use the same neural network. You can use YOLO or TensorFlow for the computer vision. You're going to use some other algorithm and neural networks for other things. So it really depends on the use case. And then sooner or later, your thing's going to work in container on your MacBook or something, and you want to put this in production. Here, you need to understand the piece of infrastructure. How you're going to spread the computability on different nodes and scale your model. And this is where you need to have understanding of Kubernetes, which is the de facto orchestrator for containers.
Matthew, I want to ask you a question there. When you're enabling customers or partners, do you have a paint by numbers approach where they can grow from where they are today to being self-sufficient in this environment? Is there something on the local environment where we can have I call it a paint by numbers enablement, or is there a breadcrumb training trail?
Path to mastery, like a path to mastery.
Yeah.
Yeah, absolutely. We do have that. We have now, it was weekly, it's now monthly. We have our enablement sessions, absolutely.
Where do folk find out about those, Matthew?
I would point them straight to rancher.com as a first step, rancher.com, and then go through the enablement. We're busy incorporating the two websites at this moment. So I'm not sure where they would be under the SUSE.com website just yet, but it's very visible on the front end of the rancher.com website. You go there, please. All those courses are available. Get involved in the webinars, get involved in the what we call rodeo sessions, get involved in all of those things. And it caters for everybody. It caters for the business person, caters for the technologist, caters for the C-suite. You know, there's something for everybody there. So definitely a lot of enablement about that. And it might be the rancher.com site, and it points you to the SUSE asset, but I would start off with going there.
You know, it's quite a scary time for South African businesses in the second year of a new world. Numbers are tight, time is tight. We're looking at high unemployment, and now we want to get fancy with edge computing and all the rest of it. It's quite a thing to dive into, and especially since we've got an existing architecture, how would we change the architecture to cater for intelligent devices to optimize IT operations? What would you say are the first 3 steps we need to take?
The large volume of data, like we say, generated by IoT device to be processed by data analytics or machine learning techniques is a task that requires extremely high network bandwidth. So that's easy to understand. And of course, associated cost by the cloud service provider. So edge computing paradigm allow you to find solutions that comply with its requirement and can make use of the fullest of the potential and capabilities of IoT. In this sense, in edge computing, the big data generated by the different IoT objects can be filtered and pre-processed at the edge of the network instead of being transmitted to the cloud to be processed there. So it's enabled faster services and reduced response time compared to only cloud computing-based scenario. So it comes back to what we said about the Ethernet ring and the high bandwidth, and so you don't have to change what's already existing because you're only going to add stuff.
Awesome.
You need to, you will add pieces to infrastructure. You will add IoT gateway, basically. These gateways that will interact with your different sensor. And so you're going to extend the border of your data center till the IoT. So you have to have this gateway to be able to communicate with your devices. Yeah.
So if the audience member, if we've got a technologist who needs to sell this to the board or to the C-suite, this is not a frightening new change. We're not going to rip and replace everything. It can be easy to enable it in a test case environment. It can be easy to enable it on a divisional case environment or on an enterprise environment.
There's also a very big misconception. And when we talk, you mentioned about architecting the solution. I think we also need to, and again, the people aspect is very key here, especially to us in this region. I think there's a big misconception that sort of AI will replace the human aspect. I heard a very interesting thing a while back. It's actually not, the better way to look at it is actually augmented intelligence, not artificial intelligence. It's augmented. Yeah. You certainly still need that human skills. I think it's just those human skills are going to be cultivated into other areas, So I think if you look at a bank teller, for argument's sake, a bank teller was always a transactional person. And typically that person could be seen as under threat, because that could be replaced by digital, mobile, or just, complete artificial environment. But actually that bank teller sort of changes. It now can sell bank products. So it's just a matter of changing that skill set. And what I think it was Deloitte that put out a thing a little while ago, that skilled workforce is absolutely successful to a successful automation program. And, those high-tech industries need to focus on recruiting that sort of next generation skilled workforce. So I think jobs might change slightly, but people are certainly, in terms of the architecturing, there's still a massive component of workforce still needed.
Excellent. I really like that answer. Hemu has asked again, can you, Matthew, provide a use case that was implemented in South Africa with regards to harnessing edge devices? No company names need to be used if it wasn't successful. If it was successful, sell away, man, sell away. Tell us who it was.
I can't mention names, but I can certainly, that example that I used in my opening statement about a transport and clearing company, absolutely. That was a huge successful project, Hemu. And you could probably hazard a guess as who it would be, but I can't mention it. But, that sort of getting goods out of the central underground, getting it and moving it offshore, that whole process was very successful IoT/edge project.
So we've got one more question, which is, how would small to medium businesses adapt to the changing environment of IoT, AI, edge computing? I feel they're at a risk of being left behind. Are these out of the reach, the solutions that we're talking about, edge computing, out of the reach of small to medium businesses? Is this only the realm of our big enterprises with hundreds of millions of euro turnover?
So I don't think it's out of the realm. I really don't. I think it depends on your business model. If your business model does not require edge, then don't panic about it. But if your business model has a competitor that might be utilizing that because it's a bigger organization, then you need to maybe, that's a business discussion you need to have, but it's not necessarily a technical discussion. But I don't think it's out of the realm of anybody. I think sensors are extremely cost effective. Edge devices are extremely cost effective. Gateways are extremely cost effective. Now, they're only going to get more cost effective as we move along. So it's a very difficult question to answer if we don't understand that customers,
so it's context sensitive.
Person's business, yeah. But I don't.
It's context sensitive.
I would blanket and say it's probably not.
What are you most excited about that's being released by your organization in the next 6 months? What's your focus for the next quarter? And for any of our attendees who are thinking about getting into edge computing, what is your one piece of advice for them before embarking on a project of this nature?
Okay, so my main focus for the next quarter in regards to the edge enablement. So we have many POC in retail, telco and healthcare, and also a huge one in ground transportation. So that's definitely topics I'm going to cover for the next quarter. What am I excited about and it's upcoming in SUSE Rancher for the next 6 months? Definitely 2 projects. First one would be the maturity around the Rancher fleet, FLEET. And so since K3S, which is like a lightweight version of Kubernetes designed for edge, since its adoption has exploded in terms of popularity, so has Kubernetes on the edge. And so an organization have adopted an edge deployment model where each device is a single or 3 node cluster. That's a very small one. So the point is that we are dealing with lots of small cluster, not a single large cluster with many nodes. Pretty much anywhere people are running Linux today, and they are looking to use Kubernetes to manage the workload. So while most K3S edge deployment are at least 10,000 nodes, some will soon get 2 million. And so the most important takeaway is that Fleet will help you scale requirements, basically. The second project to excite me, it's the SLE Micro, which stands for SUSE Linux Enterprise Micro.
Micro.
Okay.
It's a micro OS for edge.
Yes. Yeah, ultra reliable, lightweight, built for edge computing. It comes with enterprise-grade answer to requirements in terms of hardening, security, and compliance. And enterprise want edge and embedded applications that are secure, require minimal maintenance, and easy to deploy at scale. So that's a very interesting operating system for the edge. Yeah.
Advice, one piece of advice for a customer going down this road?
I will take it on the infrastructure side. I suggest to be clear about the certification expected. I might sound like redundant talking always about certification, but I've seen many things here. So also be clear about the hardware involved and the resource available. One of the first things you're going to pick is probably the hardware. It's going to come as soon as you think about the use case. Quickly, you're going to find the sensor or the gateway making this possible. And so the hardware involved quickly in the reflection. So if you are not going to address a mass market like phone, TV, or car, then probably a commercial on-the-shelf approach in terms of operating system would be less risky than a tailor-made operating system. This would be my piece of advice.
Awesome. That's solid. Matthew?
So again, lots of POCs out there. We are busy with a POC in a company in Namibia, a group company. They're rolling it out again to financial. Next 6 months, absolutely. Fleet and Christoph's answer, exactly that. So SLE Micro is a major game changer. So we're very excited about that. In terms of advice, I would say, again, get advice from the experts. Bring in a reputable company. I don't know if any of you were on the last presentation, but there was a comment was made about clients don't bring partners in because of their relationships. They bring them in because of their knowledge. So get those people in. You're not alone. This is exactly a journey. And then visit the rancher.com and visit the SUSE.com website. We have an edge solution site specifically baked for customers looking at their technologies and what they're wanting to do. So we have a lot of great information there as well. And reach out and get us involved.
Guys, next time I have you on the panel, we are starting with those 3 questions because there's so much that just got unpacked in the last 2 minutes. I would love to have visited that more. Good luck with your POCs. Good luck with the next quarter. From myself, Daniel Robus, I'd like to thank Matthew and Christoph for going off-piste, on-piste, and juggling around the questions, for TechCentral and SUSE for allowing me to host.